Okay guys, let's talk about the first part of equilibrium. I've broken this into two pieces because it's a rather meaty section of the exam. And parts 1 and 2 combined are about 12% of the exam. So you should understand that equilibrium is a dynamic process. It is not when the reaction stops. It's when the rate of the forward and the reverse reactions are equal. Direction of a reversible reaction, you should be able to tell which direction would be favored. You should be able to write the expression for both the forward and the reverse reaction. And you should understand how those two K values would be related. So you can look at Q versus K, and you should also be able to tell me how to convert Kp and Kc. And when at equilibrium, K equals Q, and so they are at equilibrium, the forward and the reverse reactions are equal. You should be able to take that equilibrium expression and write it from a balanced chemical equation. The conversions between Kc and Kp will not be tested. However, you should understand that relationship. So, calculating the equilibrium constant, if you're given pressures or concentrations, you should be able to calculate the K for that reaction. If you are given some information, you may be required to do an ICE table to determine these, because you would have K, and you could say the initial concentration of a reaction is whatever molar, and where it would lose X and gain X, and take care of stoichiometry at the same time. The magnitude of the equilibrium constant, if K is very large, then the equilibrium lies very strongly to the products. If K is very small, the equilibrium lies very close to the reactants. There would be very little disassociated with that. A classic example of this would be strong acids and weak acids. Strong acids have very high K values. It's specifically called Ka. And weak acids have a very small Ka. You should be able to understand how to manipulate K. If you reverse the reaction, then you invert K. It becomes 1 over K for the new K. If you multiply through by a factor to the reaction, K is not just multiplied by 2, but it is raised to that power of whatever coefficient you have done. And calculating equilibrium concentrations, again, this would be from our ICE tables. If you're given K, you should be able to calculate what the concentration should be at equilibrium at a given temperature. So I'm going to stop here, and I'll talk about these on my very last video. Thanks for watching.